Element stiffness matrix for beam element. The potential energy for the system, we consider the integral as summation over the integral over the elements. The potential energy of the system, we consider the integrals as summations over the integral over the elements. The element strain energy UV is equal to half into EI integral d square V by dx square whole square into dx. This is equation 1. And dV by dx is equal to 2 by LE dV by dz, and d square V by dx square is equal to 2 square LE square d square V by dz square. 4 by LE square d square V by dz square. Then substituting V is equal to HQ, therefore d square V by dx square whole square is equal to Q transpose 16 by LE power 4 d square H by dz square transpose d square H by dz square into Q. D square H by dz square is equal to 3 by 2 xi minus 1 plus 3 by 2 xi 2 to LE by 2 minus 3 by 2 xi 1 plus 3 xi by 2 into LE by 2. D square H by dz square is equal to 3 by 2 xi minus 1 plus 3 xi by 2 into LE by 2 minus 3 by 2 xi 1 plus 3 xi by 2 into LE by 2. And substituting dx is equal to LE by 2 into dz, and equation 2 and 3 in equation 1. So equation 2 and equation 3, these two equations substitute in equation 1, we get UV is equal to half into Q transpose 8 EI LE cube integral minus 2 1 to 1 9 by 4 xi squared 3 by 8 xi into minus 1 plus 3 xi LE minus 9 by 4 xi squared 3 by 8 xi 1 plus 3 xi to LE. Next, minus 1 plus 3 xi by 4 whole square LE square minus 3 by 8 xi minus 1 plus 3 xi LE minus 1 plus 9 xi square by 16 LE square 9 by 4 xi square minus 3 by 8 xi 1 plus 3 xi LE. Next row 1 plus 3 xi by 4 whole square LE square. This matrix is symmetric matrix. UV is equal to half into Q transpose 8 EI LE cube minus 1 to 1 9 by 4 xi square 3 by 8 xi into minus 1 plus 3 xi LE minus 9 by 4 xi square 3 by 8 xi 1 plus 3 xi LE. Next row minus 1 plus 3 xi by 4 whole square LE square minus 3 by 8 xi into minus 1 plus 3 xi LE minus 1 plus 9 xi square by 16 LE square 9 by 4 xi square minus 3 by 8 xi into 1 plus 3 xi into LE 1 plus 3 xi by 4 whole square LE square. Each term in the matrix needs to integrate. Each term in the matrix needs to integral minus 1 to 1 xi square 2 xi, the value is 2 by 3, minus 1 to 1 xi dz is equal to 0, minus 1 to 1 dz value is 2, minus 1 to 1 xi square dz is equal to 2 by 3, minus 1 to 1 xi dz is equal to 0, minus 1 to 1 dz is equal to 2, minus 1 to 1 xi into dz is equal to 0. This result in the element strain energy is given by U is equal to half into Q transpose K into Q. The element stiffness matrix K is equal to EI by L cube 12 6 LE minus 12 6 LE 6Le 4Le square minus 6Le 2Le square minus 6 minus 12 minus 6Le 12 minus 6Le 2Le square minus 6Le 4Le square. This result in the element strain energy is given by UV is equal to half into Q transpose KE Q. The element stiffness matrix is K is equal to EI by L cube 12 6Le minus 12 6Le 6Le 4Le square minus 6Le 2Le square minus 12 minus 6Le 12 minus 6Le 6Le 2Le square minus 6Le 4Le square. Element stiffness matrix for beam element. Next, load vector. The load contribution from the distributed load P in the element is first considered. We assume that the distribution load is uniform over the element. This is the uniform distribution load. Element nodes is 2. The load is acting on direction and P. Length of the element is LE. The load vector, the load contributions from the distributed load P in the element is first considered. We assume that distributed load is uniform over the element. The force, so integral E PV into dx that equal to PL by 2 minus 1 to 1 V is equal to HQ minus 1 to 1 into H into dz. Substituting from the H from H1, H2, H3, H4 values, H is equal to H1 LE by 2 into H2, H3 LE by 2 into H4. Therefore, minus 1 to 1 V PV into dx that equal to FE power transpose into Q. Therefore, FE is equal to PL by 2 PL square by 12 PLE by 2 minus PL square by 12. FE is equal to PL by 2 PL square by 12 PL by 2 minus PL square by 12. The load vector. Element stiffness matrix for the beam element. The potential energy of the system, we consider the integrals as summation over the integral over the element. The element strain energy U is equal to half into EI integral d square V by dx square whole square into dx. This is the equation 1. Next, dV by dx is equal to 2 by LE dV by dz, and d square V by dx square is equal to square 2 square 4 LE square d square V by dz square 4 LE square d square V by dz square. Then substituting V is equal to HQ, d square V by dx square is equal to Q transpose 16 by LE power 4 d square H by dz square transpose d square H by dz square into Q. This is equation number 2. D square H by dz square is equal to 3 by 2 xi minus 1 plus 3 xi by 2 into LE by 2 minus 3 by 2 xi 1 plus 3 xi by 2 into LE by 2. This is equation number 2. Substituting dx is equal to LE by 2 into dz and equation 2 and 3 in 1. These two equations substitute in equation 1. U is equal to half into Q transpose 8 EI L cube 9 by 4 xi square 3 by 8 xi into minus 1 plus 3 xi LE minus 9 by 4 xi square 3 by 8 xi into 1 plus 3 xi LE minus 1 plus 3 xi by 4 whole square into LE square minus 3 by 8 xi into minus 1 plus 3 xi LE minus 1 plus 9 xi square by 16 LE square. Next to 9 by 4 xi square minus 3 by 8 xi into 1 plus 3 xi into LE 1 plus 3 xi by 4 whole square to LE square. Each term in the matrix needs to be integrated. Minus 1 to 1 xi square dxi is equal to 2 by 3 minus 1 to 1 xi into dxi is equal to 0 minus 1 to 1 dxi is equal to 2. This result in the element strain energy is given by UV is equal to half into Q transpose Ke into Q. The element stiffness matrix is K is equal to EI by L cube 12 6LE minus 12 6LE 6LE 4LE square minus 6LE 2LE square minus 12 minus 6LE 12 minus 6LE 6LE 2LE square minus 6LE 4LE square. Element stiffness matrix EI by L cube 12 6LE minus 12 6LE 6LE 4LE square minus 6LE 2LE square minus 12 minus 6LE 12 minus 6LE 6LE 2LE square minus 6LE 4LE square. Element stiffness matrix for beam element. For load vector, the load contributions from the distributed load P is first considered. We assume that the distributed load is uniform over the element. So this is the beam uniform distribution load. Load vector integral PV into dx that equal to PL by 2 minus 1 to 1 h into dz into q. On substituting for h from h is equal to h1 Le by 2 h2 h3 Le by 2 h4 that equal to Fe into q minus 1 to 1 PV into dx is equal to Fe transpose q. Therefore, Fe is equal to PL by 2 PL square by 12 PL by 2 minus PL square by 12.